Hello, and welcome to the 11.4 homework. This is surface area and lateral area of solids. We'll call them solids, three-dimensional figures. Alright, so name the figure. Here we have a excuse me. We have a six-sided base, and there's two of them. And a six-sided figure is a hexagon. We're going to call this a hexagonal prism. You got to be like really proper hexagonal or octagonal or pentagonal or trapezoidal, things like that. You just it's kind of weird. But that's a hexagonal prism. Whereas this one is definitely a pyramid, and the base has 5 sides. So for 2, it would be a pentagonal pyramid. Pentagonal pyramid. Number 3. Identify the solid given its net. So this is the net, and you can see that we got 2 bases, and it's a pentagon, so it's definitely pentagonal. Would this be the net of a pyramid or a prism? Because the faces are rectangles, that would be a prism. Whereas the faces of a pyramid are triangles. And then lastly, number 4, sketch the net. We've got 2 triangles and then a bunch of rectangles. So the net would be something like this. You'd have yourself a triangle, and then 3 rectangles. Now, let's say this. The height is 8 for sure, so we can call this dimension 8. If this length here is 12, that makes this length 12, because these two have to match up if they were folded onto each other. And if this was 8, let's call that 18, and the other is 12 as well. That would fold up correctly. That's what we're looking for. Now on to the nitty-gritty here. Number 5. Find the surface area and lateral area of the following round to the nearest integer. Okay, so first of all, what type of shape is this? What type of shape is this? This is a prism. There's the base right there. That's a 3, 4, 5. That's 6, 8, 10. 3, 4, 5. So that makes it a right triangle. Here's the base right here. That's 8, 6, and 10. Now, to find the surface area of a prism like this, you have to use the formula 2 bases plus height times perimeter. This is the lateral area. When I add the 2 bases, that's the surface area. So I like to just go in here and do something like that. So what is the area of the base? Area of the base. This is a 6 by 8 triangle. The base is 6, the height is 8. So 6 by 8 is 48 times a half is 24. The height of the prism. Now this gets confusing. The height of the base was 8. But that's not the height of the prism. The height of the prism is how far is this triangle from this triangle. That would be 6. Height of the prism is 6. That gets confusing. There are 2 different h's in this problem. There's the height of the base, which was used to calculate the area of the base, and there's the height of the prism, which is 6. And now we got to do the perimeter of the base. So the perimeter is 8 plus 6 plus 10. What is 8 plus 6 plus 10? That's 18 plus 6 is 24 as well. Alright, so now we just plug that into our calculator. 2 times 24 plus 6 times 24 is 192 centimeters squared. Alright, on to number 6. Number 6. This one's quite a bit easier. And by the way, this was your lateral area right here. Surface area, and then this was your lateral area. Number 6, I'm just going to do surface area for the rest of these. You can do your lateral area on your own. Number 6, surface area of a cylinder is 2 bases plus that. You can find that on your formula packet, and there it is. So this one's pretty straightforward. You just plug in the radius. Now because these both have pi's in them, I can actually make my answer real nice and pretty by doing this. Let's see here. There we go. This is just 49 times 2, which is 98 pi. So I got 98 pi there. And this is 7 times 12 times 2, which is 168 pi. So I can just add these together to get 266 pi. That would be the exact answer for that, and I can do that because those are like terms. From there I can approximate, multiply it by pi, you get 836. And what are our units for this one? Meters squared. Number 7. We have ourselves a cone. So the surface area of a cone, and by the way, up here, here's your lateral area right there. The lateral area would not include the bases. Alright, for 7, we have a cone, so the surface area is 1 base. We can do better than base. The base is a circle, so we can say pi r squared. Alright. Pi r squared plus 1/2 LP. I should probably check my formulas for that. And pi RL. See, that's what happens. Pi RL. That's the surface area of a cone. So all you do is plug in for this one. The radius is 7. And once again, the radius is 7. And the slant height is 15.7. Because there's already a decimal here, I'll just go ahead and plug this all into my calculator. Alright, so we got pi times 7 squared plus pi times 7 times 15.7. Oh, 499. Approximately 499 kilometers squared. Number 8. For number 8, we got ourselves another cone. You know what? I'm going to leave that for you guys to do because it's basically the same problem as number 7. Let's take a look at number 9. Number 9 starts to get a little complicated. Number 9, what is this? This is a pentagonal prism. So being that it's a prism, 2 bases plus HP. Let's plug in the easy stuff. The base area, we're going to have to do some work to find that. The height is 11. The perimeter is 6, 6, 6, 6, 6. So 5 times 6 is 30. The hard part is figuring out what is the area of that pentagon. How do you find the area of a regular pentagon? you have to use 1/2 apothem times perimeter. That was an old lesson. That was 11.3. So the apothem they give you is 4.1. The perimeter is 30. We already figured that out. So therefore the area of this pentagon is 1/2 times 4.1 times 30. 61.5. That was a little tough to find, the area of this base, but it was 1/2 apothem times perimeter, and we end up getting 61.5. Now plug all that into your calculator, and we can get our final answer. 2 times 61.5 plus 11 times 30. 453. And that would be centimeters. Nope. What was it? Yeah, centimeters squared. Alright, on to number 10. Number 10. We have ourselves a pyramid. And to find the surface area of a pyramid, you do one base plus 1/2 LP. That's the lateral area. When you add the base, you get the surface area. Now for 10, the base is pretty straightforward. It's a 10 by 10 base. 10 by 10 square, so 100. The perimeter is easy. That's 10 plus 10 plus 10 plus 10, which is 40. And the slant height is given to you, 8.6. Well, that makes that easy. All you gotta do is plug in for that one to get your answer. So let's plug in 100. Let me just clear that out. 100 plus 0.5 times 8.6 times 40. 272. And we're doing kilometers squared. Number 11. Ooh, another hard one. This might be the hardest one of the day. So I'm definitely going to give you this one on homework. It is a pyramid. This is a prism. This is a pyramid. This is a pentagonal prism. Pentagonal prism. Pentagonal pyramid. Alright, so being that it's a pyramid, we've got one base, and then plus 1/2 LP like that. Alright, is any of this easy to plug into? Do we know what the area of the pentagon is? No. Do we know what the slant height is? No. The height is 11, but the slant height is unknown. Do we know what the perimeter is? Yes. 7, 7, 7, 7, 7. So 7 times 5 is 35. So we know something. Do we know anything else? No, we don't really know anything else. So let's go ahead and find the slant height first. We can make a right triangle right here, and that would look something like this, with this as 11 and this is 4.8. Alright, now we just can use the Pythagorean theorem to figure out this height right here. 11 squared plus 4.8 squared, 144. Square root of 144 is 12, roughly. Alright, so therefore our slant height is 12. That's nice. But we still need to figure out the area of the base. So let's look at this thing. How do you find the area of a pentagon? Same as before, 1/2 apothem times perimeter. Do they give you the apothem? Sure do. Apothem is 4.8. Do they give you the perimeter? Sure do. 7 times 5, which is 35. So therefore the area of this thing is 0.5 times 4.8 times 35. 84. Alright. So we have the area of the base using a pentagon, 1/2 apothem times perimeter. We have the slant height. We had to use Pythagorean theorem for that. And we have the perimeter of the pentagon. That is everything we need to plug in. Now I can just plug this into my calculator and figure out what the answer is. 84 plus 0.5 times 12 times 35. 294. And we're working with inches for this problem. Alright. Oh, this is just the lateral. So if you're looking for lateral area, it's this part right here. When I add the base, I get the surface area. The surface area is always bigger than the lateral area because the lateral area does not include the base. Number 12. We have ourselves a sphere. The only thing you need in a sphere is its radius. There's the formula. So once you have the radius, you're good to go. It says the diameter is 2, so the radius would be 1. 4 pi. And 4 pi is about 13 if you round it. Number 13. It's getting a little bit more complicated. Find the surface area of the composite shape. So this is made up of several types of shapes. So let's break this down. What do we want? If I were to paint this, I would paint the curved part of this cone. So that's the lateral area. I don't want to include the bottom of the cone because I wouldn't paint that if I was painting this shape. Then we have to include the lateral area of the cylinder. I'm not going to paint this part. I'm not going to paint that part. I'm not going to paint the bottom. Actually, I'm going to paint the bottom, but I'm just going to think about it as a circle. So there we have it. That's all we need. So let's figure this out. The lateral area of a cone is pi RL. The lateral area of a cylinder is 2 pi RH. And the circle is just pi r squared. So pi RL, the radius is 5. And the slant height is 13, so they gave us that. The radius is 5, and the height is 12. That's 12. That's 13. And then for the circle, the radius is 5. Let's keep going. We can make this one pretty. 5 times 13 is 65. 5 times 12 is 60, times 2 is 120, and that's 25 pi. Now add that all up. 65 plus 120 plus 25, 210. That is 210 pi altogether. So the surface area of this cone part was 65 pi's. This was a much bigger surface area, coming in at 120 pi's, and the bottom was just 25 pi. It all added together to 210 pi. So 210 times pi is roughly 660. And what are we working with here? We're working with centimeters. Another page bites the dust. Here we go. Next, number 14. 14, we have ourselves the surface area of this composite shape. So I'm going to break this down, and I'm going to call this the base. think of this as the base. And for this base, we've